Assalamu alaikum wa rahmatullahi wa barakatuh. I hope those are watching right now this tutorial are doing great and having good health. This video is about metal extraction, especially iron extraction by the blast furnace. So you know that this is very important as we are studying the metal extraction process. I hope you have already watched my video based on the steps of metal extraction, and then I have uploaded some metal extraction process of like sodium, aluminium, zinc, and this is about iron. So I hope you know that this is a huge, 60 to 70 meter long blast furnace which will be used to extract iron metal. And this is actually important because there is some reaction happens in different temperature. So this temperature, to remember this temperature, and also according to those temperature the reactions is important. I hope you know that what is ores, what is minerals, as the ores and minerals and all other basics is clear. Now you know that there are some ores of irons that is used to extract that metal, which is magnetite, limonite, hematite, siderites, even pyrites. So I have written 4 ores like magnetite. The formula is Fe3O4. Fe3O4, that is ferrous or ferric oxide, where we got 72.4% iron. In other case, hematite, that is Fe2O3, which is ferric oxide, iron 3 oxide. So here we got almost 70% iron, which is comparatively less than magnetite. So hematite is one of the most used ores to get the iron extraction, and then siderites, which is ferrous carbonate, where we got almost 48.2% iron. In other case, limonite, we get 55% iron. So in blast furnace, well, ores is being collected and then it is sent here with some other things, and some series of reactions is happening inside. This tutorial is focused on that. So what is basic? That we got ores, and then from ores we need pure metal. We need pure metal. But this is actually not easy. There are a lot of things actually associated with that. Cost, labor, and some management, and some other things is also associated with this. So the ores extraction, and then from ores to having the pure metals using the appropriate steps and mechanism, it's not easy. Because we know the steps, if you can remember that when we get the ores, what we need to do first, we need to crushing and grinding. After that, crushing and grinding, after this process, what we need to do, we need to concentrate. So then the next steps is concentration of the metal. I hope you know there are several processes like flotation, leaching, gravitational separations, hydraulic process. I hope you know that the magnetic separations. There are some other process based on the different elements or different metals. The steps are different. All steps are not applicable to extract all type of metal. It depends on the element. So concentration, you know that concentration is again a very important steps. Then after, what happens? The roasting and calcination. I hope you definitely remember the name of the roasting and calcination. I have already explained these, that which particles from which particle difference. And then after, what happens? After the roasting, reduction, and then refining, and then we get the pure metal. So from ores to pure metal, this is our demand. We need the metal because we have to use it at the next level. But to get from ores to metal, pure metal, we need to follow this process. So this is in general which is not applicable in all sort of metal, because this is different, and that is the thing that I have already explained in the first tutorial where metal extraction steps has been discussed. But in this video I'm just giving a reminder that this is the step. First we need ores. So what is the ores of iron? You should remember the name, which is hematite, magnetite, siderite, pyrites, limonite. So magnetite, you must remember the percentage of iron which is actually heavier and comparatively more in case of magnetite, and comparatively less in hematite, and then limonites. So what is the steps? Crushing and grinding, concentration, roasting and calcination, reduction, refining, and then pure metal. So now, as we are studying right now the iron extraction, so we are using hematite, magnetite, and these sort of ores to get the iron. Now you think about the blast furnace. This is almost 60 to 70 meter and 120 feet long, and there are some zones. There are some zones of this blast furnace. The last part is known as hearth. Hearth. The middle portion is known as stock, and the other part, the upper part, is known as wash. In other way, the side, the way that the ores, the limestone and the coke powder together is being given into this way, and this way is known as the throat of the blast furnace. This is hugely heated. The average, the heat is actually here 300 to 400 degrees Celsius in the upper part, and in the lower part it's nearly 1500 degrees Celsius or 1600 degrees Celsius, like this. So you see the differences, the range between this temperature, and there are some specific reactions that is happening in these steps by steps, and that steps is very important to remember. Now think through the throat, all the ores, coke powder and limestone is being given through this shuttle, and then it's coming to here, and then the whole thing is happening with the presence of hot air. And this, you see the circular space, this is called tuer, and this tuer is used, the blown of the hot air inside the blast furnace. So here the hot air is being blown to react with what? And that is why the temperature of the lower side of the bottom of the blast is much higher, which is nearly 1500 degrees Celsius. And if you go up, then the temperature is lessening, like 1500, 1200, 1100, then thousands, then 900, and then 300, 400 degrees Celsius at the top of the burn. So this sort of range is important. Why? Now you see that when you are actually giving all these ores together, carbon powder, coke powder, and hematites, iron oxide, all of the things is being here, and then hot air is being blown up here, then what happens? The oxygens, the air is moving upwards. It's moving upwards, and then first thing is that carbon that is solid is reacting with oxygen, first reaction. So when coke powder is reacting with oxygen, then it will produce carbon dioxide. This is important. Carbon dioxide. Secondly, what happens? This carbon dioxide is reacting with more carbon, and then it is producing carbon monoxide. And this is very important here to remember that this carbon monoxide is the main reducing agent is working here. So carbon monoxide is the strong and main reducing agent that will be working here to extract iron. Because we are giving what? We are giving iron oxide. So what we want? Only iron. We don't need oxygen. So we need to remove this oxygen. Who will take that? Any reducing agent? Carbon alone cannot reduce iron oxide. That is why carbon monoxide is doing the job. And that is why carbon monoxide is the main reducing agent of the blast furnace. So the third reaction is that this carbon monoxide will react with Fe2O3, and you see, you must remember this thing, and I should write here that this carbon monoxide is the main reducing agent, the carbon monoxide. So carbon monoxide is reacting. Now it will be working as a reducing agent, and then what will happen? This carbon monoxide will release oxygen. So there are 3 oxygen atoms, so similarly we need 3 carbon monoxide, and then it will be like iron will be released and carbon dioxide will be as a carbon dioxide. Okay, so this iron is released when the carbon monoxide is acting as a reducing agent. Then the main important thing is that you must remember that limestone, that calcium carbonate, is broken down. That is called the thermal decomposition will take place in near about 600 to 1000 degrees Celsius, and it will be producing as a calcium oxide and carbon dioxide. Now you think this calcium oxide will create another role, that is actually it creates the slag, the silica or the sand. This is sand that is actually mixing with that iron ores. Now it will be reacting with calcium oxide, and then it will produce calcium silicate, which is actually a slag. So this is a slag that is simply, it's not required. So calcium silicate, we don't need this. This is a simply unwanted products, because the ores, through the process of metal extraction like crushing and grinding, concentrations, roasting and calcinations and all other things, but sand and sort of like other unwanted things still there, so we need to remove. But this is also not sure that the iron that we are getting here is totally 100% pure. No. So this silica, that is sand, this is actually sand, will be reacting with calcium oxide, and then it will be producing calcium silicate. Now you think the differences between this carbon and carbon dioxide, that things is happening here, which is called actually combustion reaction, and this part is known as combustion zone, the zone of combustion. So simply we can write the zones of the blast furnace inside, so that you can actually remember what is going on. You see, the first reaction, that carbon and oxygen is producing carbon dioxide, and more carbon monoxide is creating here. So this is the zone of combustion. So we say this is combustions zone. And then what happens? The other side, when actually the iron oxide, this is actually reducing here. So iron oxide is reducing by carbon monoxide to produce iron and carbon dioxide. That is actually what is happening. This is reducing. So reducing zone. And then in other side, when temperature is 900 to 1000 degrees Celsius. In that case, this calcium carbonate is breaking down to produce calcium oxide and carbon dioxide. So here it's called slag formation zone. This is called slag formation zone. So there are different zones, and where the different temperature is being used to react with different reactant. So firstly, that carbon dioxide and carbon monoxide is producing, and that is called the combustion zone. The iron oxide is being reduced by the carbon monoxide, and that is called reducing zone. In other side, that calcium carbonate is thermal decomposing to produce calcium oxide and carbon dioxide, and that calcium oxide will produce slag, and that is why this is called slag formation zone. So in this case, the temperature varies from 1500 degree to 1600 degrees Celsius to 300 to 400 degrees Celsius. Now one thing is very important. When slag is formed, it definitely stores in the upper part of the molten iron. This iron is actually solid because the temperature, when it reaches 1500 degrees Celsius, then iron actually melts. So molten iron is stored at the bottom of the blast furnace, and the slag is being stored here just upward of the bottom of the blast furnace. So the slag will be collected through this way, just upward of the molten iron, as because the density. The molten iron is highly dense. I mean, that is why it has a more weight, so it comes the lower part of the blast furnace. So this is densely, and less densely slag is stored in the upper section. That is why iron is being collected through this way, and slag is collected through this way. So I hope you can remember the reactions that is happening where there are some other zones, but very simplifying, and I'm just giving you a very simple explanations, and you can study a lot more about it because there are a lot of things which I didn't say right now. But according to the syllabus, if there is any questions come from the explain the iron extraction process, then I hope you can write down these things, and also this data can be useful. So I hope you see what is going on, that ores that has been collected from the minerals, and then these ores with limestone and coke powder is given through this process, and then the reaction starts with huge air and huge hot air, and this hot air is blown to the inside of blast furnace through the tuyer. This one giving the hot air, and this air is going upwards through the slide, and this is given up of bricks. So it's going up, and when it going up, this oxygen first react with carbon. So then carbon and oxygen is producing carbon dioxide, but I need carbon monoxide. When more carbon dioxide is reacting with more carbon, then in the second stage it produces carbon monoxide. This is very important, that which is the main reducing agent of blast furnace. And then this carbon monoxide will act with iron oxide, that is ferrous oxide, ferric oxide, ferroso-ferric oxide, all other ores which is actually oxide ores, then react with carbon monoxide to produce carbon dioxide. That is where reduction happen. So we can say this is a carbon reduction process, and these things is happening in the reduction zone or reducing zone. In other case, the limestone is still mixed up with ores that would be thermal decomposed and produce calcium oxide. That is the main agent to produce slag. So the sand which is mixed up with this iron oxide would be slag, and that slag would be collected from the upper part of the molten iron. So iron is collected at the bottom of the blast furnace, and then from upward slag is being collected. So I hope you understand this process, and if you don't, and if you have anything to write, please do not hesitate to write me in the comment sections, and of course I'm here to explain things in my best way, and according to your comments and your demand, I try my best to upload all these things which is actually required, and that is my passion. So hopefully see you in the next tutorial. Thank you so very much. Stay well and stay immune.